I invite Mr. Abubecker KM to deliver the session. Please.
Very good afternoon, my listeners. Mrs. Shijida Sheikh, for a wonderful introduction about myself. Shall we enter into these main sessions of our webinar? Our ultimate aim of this webinar is we have to familiarize a new platforms which is most suitable for the researchers and engineers. Nowadays, we are dealing with most of these enterprises having conventional textual language programs. After completing these webinars, I hope that most of them are familiar to programming platforms or graphical programming platforms named as LabVIEW. It is an acronym for Laboratory Virtual Instrument Engineering Workbench. Nowadays, these LabVIEW platforms are mostly used in the automobile industries, as well as the software industries, especially the TCS, Wipro, then Bosch, etc. Again, before going to these graphical programming concepts, we have to just refresh our minds. What about the concepts of what about the difference between the conventional textual languages as well as what about the graphical programming concepts? As we enter into these concepts of a program, we know that it is a set of some instructions that produces the various levels of outputs. Depends upon this programming logic, the output may be varied. It may be some scientific applications, or it may be some engineering, or it may be some physical science, or some types of anything can be defined by this program. There will be a lot of programs or programming platforms as available in our market. Sometimes the students as well as the researchers or engineers become very confused about which platform is most suitable for their research activities or their academic project or their engineering concepts or their industrial applications, etc. The ultimate aim is there will be unique platforms for engineers or scientists or researchers. It is most advanced level programming is provided to us with a minimum cost and with a minimum complexity. Okay, I can enter into these different types of the software platforms. Yeah, we know that it is a programming language can be classified into different types. The basic classifications will be starting from these machine and assembly languages. We know that what about the machine languages and assembly languages? The machine language may be some sequences of some zeros and ones that cannot be read by the human persons. It can be read by the machine system itself. The advanced level of this machine language is called as an assembly language. It is sometimes it will be most readable by a programmer or a user because it can be defined by using some mnemonics or some instructions or some other languages. Can be more readable by the user. The second type of algorithms or programming languages considered as a algorithmic languages. We know that the concepts of the C programming concepts or C programming and Fortran languages, etc. That is classified as an algorithmic languages. We know that the algorithmic languages are designed to express some mathematical or symbolic computations. It can be and express some of the algebraic operations in a notation similar to the mathematics, and allow the use of these sub-programs that package commonly used operations for the reuse concepts. And these are classified as a first level of high-level languages. Right. If you are entering this third steps, it is classified as a business-oriented languages. We know that is a COBOL and SQL. Another one is the education-oriented language, that is BASIC and Pascal. Nowadays, we are dealing with the object-oriented languages. We know that if you are entering to either any of the languages or industrial languages or open source programming languages, the backbone of that programming concept is it will be an object-oriented programming concepts. The best one of the examples is what I say C++ or Java. Most of them that are more familiar to this what about the object-oriented programming concept used in the C++ and Java. Right. This is some examples of or simple concepts of this program basic classifications of programming languages. Another classification is the next level is what about the ultimate aim of this webinar? That is called as a graphical programming languages or visual programming languages. The concept of this visual programming language is that it allows the user to specify a program in a two-dimensional tree. It is called as a 2D or two-dimensional array, 2D signals. What about the concepts of these one-dimensional signals and the two-dimensional languages in a programming language? If you are dealing with a signal or a signals or an image, we can classify it as a one-dimensional signals or two-dimensional signals. In case of programming language, our conventional textual languages are considered as a two-dimensional because it has the compiler and interpreter. We can process them as a one-dimensional stream of characters. That is, we are using some typing languages or typing these instructions or programs are using characters or mnemonics. It is classified as the language or the characters is classified as a one-dimensional language. That is normally the C++ or Java that can be considered as a one-dimensional languages. But the visual programming language is considered as a two-dimensional or multi-dimensional way of representing the signals. That is, we are converting these conventional or textual languages into some graphics or graphical representations, or it may be some figures, or it may be some icons, etc. Normally, in graphical programming, the figures are like figures or your graphical elements can be named as icons, because that is the best suitable word for representing the programming platforms in a visual programming or graphical programming. It is called as a icons. Right. Okay, that is the basic concepts of the visual program. It is a simple two-dimensional or multi-dimensional way of representing the signals. But in the conventional textual language, we are having some compilers and interpreter. That is why we are dealing it as a one-dimensional signals or one-dimensional programming languages. The another classifications of your visual programming languages, it is having three levels. The first one is your icon-based languages, form-based languages, and diagram languages. The diagram languages mean it is having some graphical representation. For example, if I want to perform this addition of a number, addition of two numbers, normally we are accessing some variable called as number 1, number 2, and perform this addition, and the sum is copied to another variable called as a third variable. But in the diagram languages, these inputs can be or graphically, graphically I can be able to access this x or first value, second value, and perform this addition, etc., etc. Right. But the one of the best suitable way of this classification of the VPA languages is an icon-based languages. For example, if it is a diagram language or form-based languages, we are using some graphical user interface. It is better to identify the difference between these graphical programming languages and the visual programming languages. Then what about the visual concepts of this? Or is there any relation between the visual programming languages and the graphical user interface based programming? It does not have, because so many cases we are most confused whether this GUI based or graphical user interface based programming is same as a visual programming or graphical programming languages. That is actually GUI. It is most probably used for some authorizing the services, how they are their code or their context is completely a textual. But it can be, but it is too much confused about whether it is a graphical program. It is a simple graphical user interface. It is not a graphical programming or visual programming. But in the visual programming languages, for example, while we are considering these concepts of Visual Basic or Visual C++ or some other platforms of the Microsoft or some other softwares, we are confused that whether it is a visual programming language or not. Actually, they are only textual languages which uses some graphical user interface to build a programming interface as easier. Right. So we have to leave these concepts of what about these graphical user interface or textual programming languages, etc. We are dealing only with the graphical programming languages or visual programming languages. Most probably the engineering platforms or scientist program platforms in VPL languages is mostly an icon-based programming languages. One of the best examples of these icon-based programming languages is LABI. LABI stands for the Laboratory Virtual Instrument Engineering Workbench. It is provided by, offered by this National Instruments. Yeah. It is in this example, in these platforms, the most of these devices, for example, every type of engineering or science branches can be accommodated into a single platform. Nowadays, there is an era we are dealing in this deep learning of machine learning concepts. We are starting from this top. The laboratory or lab platforms has already, actually it is a simple virtual instrument workbench. That is, we are trying to imitate the presence of different hardware devices in a single platform. The best example is, for the better understanding, I can say that we are more familiar with this part about the cathode ray oscilloscope. Right. How to implement this concepts of how to implement this cathode ray oscilloscope into a C++ program or a Visual Basics or some other graphical user interfacing. It is too much complicated because we have to write a lot of programs. It may be in the megabyte order. That will be hundreds or thousands of pages is required to simulate or virtually imitate this presence of a cathode ray oscilloscope in a Visual Basic program. But in the LabVIEW environment, there is a single block is there. You can just copy this or access the cathode ray oscilloscope from this library and paste into their work area. And I can able to apply these signals or it may be some digital signals or analog signals or voltage or current. Any type of signals can be connected up virtually toward this input terminal of the cathode ray oscilloscope. I can able to measure the signals by using the cathode ray or CRO. Similar to most of this engineering, for example, in our robotics industries, there is a lot of graphical user interface programs or programming languages are available for robotics industries, but it does not have it does not offer this 100% efficiency, because after simulating this environment for the robotic arm or robotic design, maybe the software will have this 100% efficiency. While we are rendering this real time, there is some mismatching between the different degrees of freedom or there can some types of angle of rotation so joint. That may not be there will be possibilities of getting an error during this implementation level. But in this platform called as LabVIEW, it is purely a perfect platform for designing the robotic applications, or it can be more suitable for the aeronautics applications, or another engineering stream is it can be more suitable for your biomedical applications or electronics engineers or electrical engineers, IT professionals. For every engineering branches, this laboratory platform having a solution. Our LabVIEW platform has a solution. That is why we are choosing this LabVIEW. It is most suitable for prominent for this some research lab, academies, and industries. It is best suitable for your researchers as well as the academic projects. Right? Actually, it is a simple graphical based. That is already we know that it is a graphical based programming languages. The next thing is, what about this virtual environment? We already told that there is a platform called as a virtual instrument. It is a virtual instrument used to create our own designs or our own programs. It may be some virtual programs also supported. It may not be limited. It is not limited to hardware or graphical program or graphical based programming. It can also support your the C++ program or your Java program. Both are supported. And another advantage is these LabVIEW platforms can be converted these LabVIEW programs into the C++ program or C program. Right? That is, C program can be converted into a LabVIEW environment or virtual instruments, or this VI or virtual instruments can be again returned back to a C++ or C program. That is the advantage of a LabVIEW platforms. Right? And another one is the platform is called as it is a virtual instrument. That is normally when we are dealing with a C++ program or C program, we are calling it as we are saving this program as program name.c or program name.cpp and so on. And this working platform is called as a virtual instrument, and these programs can be saved as the program name.vi. Right. That is not very important, and just programming say that. Another feature is the programming language that is already discussed is that the C or C++ or any type of textual language program is supported, or in these types of functions or subroutines also supported in the LabVIEW platforms. Okay, that is why you can assume that we are entering into some researches or research level or engineering levels or project level using this laboratory virtual instrument. During some after levels or some succeeding levels, we can feel some difficulties for writing this program by using this virtual instrument. There is a possibility we can continue this program by using the known languages. It may be some either or C++ or C program or maybe Java. That remaining sections will be completed by using a C++ or C program, or the program or textual program known by the students or known by this programmer. That is one of the advantages. That is, it is called as a multi-platform device or multi-platform environment. That's one of the best, one of the important advantages of lab is a multi-platform, more multi-platform. Another one is it's a multi-targeted. Right? Multi-target means or multi-target or multi-platform means it can be multi-platform means it can be supported either in Windows operating systems or Linux, or it may be an Apple or any type of operating system supported. And multi-target may be it can be supported even some hardware programming languages. I think it is we are not this a hardware language called as a VHDL or Verilog. This mostly dealing with electronics engineering students or electrical engineering students. It is actually the Verilog or VHDL is called as a hardware programming languages, mostly used in VLSI industries. Right. This LabVIEW platform is also having a Verilog platform, or Verilog or VHDL program or VLSI programming concept is available in this LabVIEW platform. In effect, every engineering and science streams can be implemented by using a single platform called as a LabVIEW. Right. Yeah, you can discuss some important features of LabVIEw. It is graphical user interface. It is multi-platforms and multi-target. Already we not bother about multi-platforms and multi-target. And another one is connectivity and instrument control. Actually, the LabVIEWs have been, it is not familiar to this the common community in the last 6 to 8 years. After this LabVIEW has been familiarized by the TCS as well as this Bosch industries, and they are implementing this hardware with a minimum cost on their own high-end vehicles or high-end automobile devices. The LabVIEW is most adaptable to the community. Till this last 20 years, we are not familiar with this part about the LabVIEW. It is available in the market more than 25 or 30 years back, but it is not familiar to this market or community. After the use of this combination named as the TCS and this Bosch, this most familiar to this community, and it is called as it is mostly used in the instrument control applications or instrumentation applications. Before going to this familiarization of the LabVIEW platforms, we have to just compare this, the difference between or the analogy between this LabVIEW and the normal C++. I'm just using a C programs. Right. The first one is normally the functions. The functions in the textual language is called as a virtual instruments. Right. It is very simple. Another one is we are having some commands in command in your C or textual language programs or high level languages. That commands is called as a drag and drop unit. That is, these commands can be replaced by the graphical user interface. If you want to perform some addition, for example, in C++ or C program, if you want to perform an addition, we have to use a command called as add. Right. But in virtual instruments or LabVIEW, we are having a special block called as an adder that can be copied from this library and pasted to this drag. And another one is the command window. The command window is more similar to the block diagram representations. Right. In C program, the user interface, most probably there will be some graphical user interface or GUI, mostly used in the Visual Basic or Visual Basic. It is used to interface, or it is used to interact with this user to this programming platform. That is called as a user interface. A user interface is replaced by a concept called as a front panel. Right. And the file extension is .c can be replaced by .vi. Right. And we can see that in C++ or C programming, we have to add some library files called as a hash include math.x or maths.x or math studio for the proper functions of the mathematical applications. That things can be done with the help of a script called as a math script files. Okay, similar to every things available under a textual language is available in a graphical programming languages. The concept is that the visualization process may be different. In the first case, we have to write this a lot of commands or a lot of instructions to perform the operations. But in the second case, we have to accept or we have to add some icons with respect to our applications. Okay, let's see. The complexities of the programming can be reduced by use of the icon-based programming languages or LabVIEW programming platforms. Okay. I can share. I will show you what about the programming concepts of a LabVIEW concept. Then only we can go for this another one. I think it is needed to discuss this much of theory parts. I will show you this some demonstrations of the LabVIEW environment. Then only we can identify or easily get this idea about this LabVIEW. Or I will try to show a deep learning algorithms or deep learning environment, or identify some types of objects, or to read a character, or to read a barcode, etc. We know that while we're dealing with deep learning concepts or deep learning or machine learning, it's a too much complex procedure. For example, if you are dealing with an OpenCV or deep learning or deep learning or machine learning using an OpenCV platforms, first of all, we have to list a number of supporting files or supporting platforms for performing these deep learning concepts or deep learning programs or machine learning. But in LabVIEW, there is a single block of icon or single block or single icon is enough to implement this deep learning or machine learning concept. Okay, I think it is not required to discuss too much more. I will show you. A platform named as LabVIEW. Yeah, I think it is. My screen is visible to the users. Am I right? Yeah. And this is the simple platforms or programming platforms of LabVIEW. It's having two panels are there. This left side indicates that it is a front panel. We know that. What about this is called as a user interface. It is called as a front panel in LabVIEW environment, and this is your block diagram. The programs will be executed in this block diagram, and this input and outputs, that is a front panel, will be shown. You can assume that I'm going to just say a simple adder or adder subtree or perform addition of two integers or two floating point values. Sorry. As in C++ or C program, we have to declare the two variables x and y, or another variable, third variable called as sum, and perform this addition. The minimum 6 or 7 steps is required to implement the addition of two numbers. In LabVIEW environment, I can able to, the front panel indicates that what about the user interface. The front panel will contain what about the input and output. We are having two inputs and one output is there. Right. I am just right click on this window, and you can see that there are different types of controls are available. It is called as some numeric controls, then Boolean controls or string or any type, different types of data types are available under this LabVIEW. Similar to a conventional textual language program, it is also having some data types, right? Similar to the C++ C program. You can see that I will, in this example, I have to access maximum a numeric data types. Okay, I am choosing this numeric data or numeric control. Here we are having some numeric control is there and numeric indicator is there. Numeric control means that will be an input, and numeric indicator is it is an output. Okay, and various types of control and indicators are available. This is a simple numeric control, and this is a simple fields, either it's sliding types or maybe some knob types or thermometer types. That is, it depends upon your application. You can choose what is the nature of that input. It's very easy. Right. In this example, I have a simple numeric control is here. I'm choosing a numeric control called as this one. Yeah, I'm putting this one is the first numeric control. Again, I'm going to this numeric control, accessing and another. These two are the input. Okay, I'm placing the two inputs on here. You can change the values of input by using these up and down arrows. Right? And another one is after addition, we have to display the result in numeric indicators. Right? I'm choosing a numeric indicator. These are the different things I will record for performing an addition using the LabVIEW. The front panel window, minimum 3 sections are there, 2 inputs and 1 output is required. Okay, and after placing these front panel indicators or front panel controller, definitely the block diagram, we are having three numeric systems are displayed, and first one is here, the numeric one. I representing this one is A, and this one can be replaced by the variable called as B, and this one is your this sum. Okay, I'm just replacing the name as A, B, and C. The next thing is, inside this block diagram, we have to write a program. Normally, what we have to do, the two inputs are there and one output is. That can be defined by these different variables. And these variables can be accessed through the programming itself or your C program. But we have to write this program to perform the addition of these two numbers by using some languages or by using textual languages. But in LabVIEW, there will be a special order circuitry is there or graphical user interface is there. For that purpose, we can just right click on that window. You can see that a lot of function windows. Actually, this windows is called as a palettes. Normally, the window, there is no word called as a window. In LabVIEW environment is called as function palettes. Okay, in function palettes, we are having a lot of things are there. Then first one is the structures. Then another one is similar to C++. We are having some array may be there. Then Boolean things may be there, then strings, then waveforms. Actually, this waveforms and graphics is mostly used for your the engineering level or your electronic students and electrical candidates. Okay, our ultimate aim is I have to perform some additions. The addition maybe it is our inputs are numeric. I have to perform this numeric addition. You can go to the numeric palette and select this add window. You can see that a lot of things are everything is available under this numeric application. It may be rounded to the nearest or the ceil operator used in MATLAB. Then round off operator is a ceil operator or base ground operator. Then increment, decrement, square root, every type of mathematical operations is or numeric applications is available under the numeric palette. Okay, so I can choose this adder and place it in the block diagram. You can see that the adder is only visible in the block diagram, not available in the panel because it is a input and output window, and it may not be display this adder in the here. The next thing is after placing these required elements or required icons. This is a first icon. You have to wire the circuitry. Then I am writing this A toward this first terminal, and B is given to the second input as the adder. Okay, definitely A and B will be added. And I have to, if you want to display the result, you should wire this output of this adder toward the indicator. Right. That is, the A is your controller, B is also controller, and sum is the indicator. Now your program is over for an addition process. This process, you can run this program. Similar to every programming language, we have to run this program by using this window. I'm just running this program. Now I am choosing this value. Both A and B is equal to 0. The result is 0 itself. I'm trying to change these values of B is equal to -1. 0 plus -1 is equal to -1. Then I'm changing this value. B is equal to 4 and A is equal to 8, and 8 plus 4 is equal to 12. Right. That is, the entire addition programs can be replaced by using a graphical user interface with a minimum 2 input signals and an adder. Similar to for every industrial applications, there is a individual block of or icons are there. For example, if I want to perform the square root of a number, there is a special icon called as square root under the numeric palette. Okay, I can stop this program and I can show you whatever the different palettes are available under a thing. For example, for a CSE candidates, we can deal with string operators or string functions. You can see that under the string functions, if you want to perform some sorting or concatenation of two strings, you know to write this program. You can go to the string palette and choose these icons. The concatenation program, placing this concatenation, you can see that there is two inputs are there, string 1 and string 2, and output will be the same data types. If you are applying the two strings toward this string concatenation, the output will be concatenated, output will be required, or output will be displayed. Okay. The only thing we have to remember is that without knowing these concepts of the programming language, we cannot be able to use this LabVIEW platform. For example, without knowing this, what do you mean by this concatenation of two strings? We cannot be able to perform the concatenation operation using LabVIEW, because if you're having an enough knowledge or basic knowledge related to this programming concept, every user can easily choose this LabVIEW platform, the programming concepts. Okay, and similar to for some other applications is I will show you that there is the file input and output operations. You can see that there is a zip icon is there. What is the need of the zip files? That is we have to apply a file that will be compressed into another file and save it. Then if you are using a Windows operating system or C or C++ program, we have to download a WinZip or WinRAR. Then only I can perform this compression for a particular images or files or any type of informations. But using these LabVIEW platforms, I can able to go to this the file input and output operation, choose these WinZip applications and use it and place it on here. Then what are the different but we have to remember, but we have to know what about the minimum requirements for programming this, for performing this WinZip or compression operations. The minimum requirement is maybe which is your files, or how many performance. What about the performance level? Whether it is a higher performance or it will be moderate performance is required. Similar to these two parameters can be defined by the user, and output will be the zipped format of your images or graphics or files or data or any type of data. Right. I think it is you can get this. What about the concepts of the LabVIEW programming? The basic thing is that without knowing these basic concepts of the programming, we cannot able to use the LabVIEW. But if you're having enough knowledge about this, basic knowledge about the programming, or the sometimes we are calling it as the programming logic. If you're having a logic, you can continue with every type of programs can be run under using this LabVIEW platforms. Okay, I think it is we are getting some concepts of graphical programming using the LabVIEW. Okay, then I will show you one of the examples for best example for a real-time example that is better for you. Okay, I can show you some color classifications. I think it is, you can see this window. Here is also, it is a pretty, I wrote this program for identifying this the color of these bottles and placing different colors. I have to identify which color is or which bottle is having our required color. Okay, I will show you the entire program and their virtual instruments. Yeah, in this case, normally we are writing this program inside this a while loops. I forgot to say that some functions. Okay, I can return back to the program. Inside this structure, okay, you can see this. Before going to this our real-time example, we have discussed what about the structures. Right? Yeah. You can see these structure palettes. We have a different icons out there. Normally, we are starting with the sequential programming using C or C++. The first concept is what about your while loops, then for loop, then case structures, etc., etc. Okay. Then you can see that inside this structure window, the for loop is there, then while loop, then case structures. Then in addition to this, we are having a lot of things are there. There is local variables. I think it is local variable and local global variable. Then shared variables are it is not new for us. We are more familiar with this part about the concepts of local variable, global, shared variable, for loop, while loop, etc. Okay. In addition to these basic structures for a sequential programming, the addition is we are having the math script file is there. When we are discussing which the second or third slide, we can say that the MATLAB or mathematical operations can be used by using a math script file. For example, if I want to perform this the square root or any other mathematical operation like this, the solving of a quadratic equations, what I have to do is that I have to place this math script file and place it on here. That is, I have to choose what about the required function palette and paste it in on your block diagram. Yeah, and you can write this program. You can write the MATLAB programs under this window. There is a separate window is available for you. The MATLAB or math script files is available in your LabVIEW. That is, when we are discussing the basic features, it is having multi-targeted and multi-platforms. Right? You can write these your MATLAB programs under the these icons. If I want to write a C or C++ or C program, we can go to the I think it is, yeah, there is some, I think it is not here. Yeah, before another example is what about here the flat sequences. Actually, the flat sequences means it is a sequential programming. For example, if you are dealing with a real-time programming or real-time scheduler or real-time operating system. Okay, the concepts of your real-time schedule is after this completion, a successful completion of a task, we can enter into the second task. Then if the second task is successful, we can go to the third. If the third is successful, we can go to the fourth and so on and so on. Okay, by using a sequential programming concept, that sequential programming concepts can be implemented by using these flat sequences. We can apply n number of windows as similar to the math script file. In this example, we can see that there are two windows are there. Okay, you can write this first scheduler on this window and right click on this program and add a frame after. I can able to add n number of frames. That is, the frame 2 will be executed after the successful completion of the frame 1. Okay, and this frame sequence, this types of program is more suitable for the real-time schedulers or programming of real-time operating systems. Right? That is not only reserved for a conventional program or an open source program. It is very suitable for the real-time operating systems also. Okay. Then another concept of another important thing is under this structure is I have to place this some formula nodes. The formula node, what about this formula node? Formula node is a simple mathematical operation. That is, we can assume that we are having a simple program for a Visual Basic program. Sorry, not Visual Basic. It is a C or C++ program or a VHDL program or Verilog program is there. We can write this program for performing this addition under this window as 1 plus 2 is equal to something like that. It will be after executing this program, 1 plus 2 will be displayed as 3 and so on. Okay, as similar to it is, we can compare this performance of this window by using with a Python languages or Python interpreter. Okay, while we are reading this Python interpreter, you know to execute this program. We can just write this program; it will be executed. You know to write this program as a step by step. This because it is an interpreter. Similar to this one, I can able to write this program under the formula node. Okay, and this event structure, that is event structure and placement structure is most related for your real-time operating system. And you can just leave this basic concept and you can go to the color classifications. Yeah. In this example, you can see that your program will be placed in the while loops. Okay. Why we are placing this program in a while loop? That is a main loop. In C++ or C program, every program will be under the main function. Similar to that one, I can place the programs inside the while loop, which is acting as a main program. Okay. I will tell you, in this example, I am trying to find this some color by giving some values called as a region of interest. I think it is the computer science people are more familiar with this. What about the region of interest? That is, for example, the region of interest is I have to find this. Where is your red color and where is your green color, etc. Okay, while we are dealing with the imaging system, the region of interest is something like that. Okay, before going to this, the region of that is here is the I am placing this. What about the color combinations or KN signals or CYAN signals or CYAN signal ratio can be defined as region of interest. Okay, before going to this, how I can read an image? Then only I can able to apply this the deep learning or color classification concepts on the different color or different images. Okay, that is why I have to read the sources. That is by using the file concepts in C program. We have to give where is your image file is saved. It can be saved in your computer systems or maybe in the portable devices. We have to give where is your place. We have to give the paths on the particular area. Then after that, we have to call a color classification or trained model of color classifications. Is right. That is why we are dealing with this image processing. We are having a lot of algorithms out there. For example, in a simple edge detection method, there is a contour detection is there, or some edge detection type. So many edge detection types algorithms are there. The only thing is that we have to add which types of edge detection is more suitable for your application. You can go to this function window and try to tap this contour detections or canny edge detections or any type of edge detection method. Similar to, I have to give some files required for this color classification method. I am using the some two color classification method, and I am giving this what about the region of interest. Okay, inside this while loops, it will be executed different files. It may be the supporting files or supporting icons required for the color classification method. We are trying to access the color classifications are images from this outside field. We know that if you are entering to this main loop, it will not go back to this outer loop. That is, these left side declarations are called as the initial declarations. While we are running this program, it will not go back to this outside of this while loop. It will be executed only inside these functions. Right? Similar to the concept, or you know that if you are entering this main loop, it will not quit to the some other areas. Similar to that one, it will be executed or it will be placed inside the while loops. Okay, I will try to run this program. I will show you what about the text. For example, I am trying to running this program. My region of interest is the CAN signals is defined as some value called as the pixel values is 298, 369, 330, and so on. It is the color, the region of interest related to these 4 color combinations are it is related to a pink color. Okay, that is we have to know that what about the CYAN signal CAN values of a pink color. Then only I can able to program this VA. Right. Just for example, I will change the values as the CAN signals are. This one will be 100, and the third will be simply 34, something like that. Okay, that may be some color variations or region interest of some other. I don't know which is your color. I will try to check out which one is identified. And I'm trying to when I'm trying to execute this program, it is identified as a yellow color with a score of an 870. That is, we have to change what about the region of interest. That's right. And the remaining things will be need not be changed because it is a fixed. We can just wire the different icons, and only we have to define which is the region of interest for a particular color combinations. That's right. But first of all, I told you without knowing this each and every theoretical part of this block, we cannot able to continue. For example, for identifying the yellow color, I have to know that what about the RGB colors or CAN signals or ratios of the CAN signals. Then only I can able to what about C, Y, A, and N signal and ratios can be defined by the region of interest. Otherwise, I don't know which is the values of yellow color. Right. So we have to know that thoroughly know the theoretical parts of different input signals as well as the output signal. That is enough. Okay, I think it is. I can try to change this another color. The CAN signals, I am changing it as a simple 0, and this one is changes it to 120. Right. I'm trying to execute this program. It is again these values. That you can see that the 2 values are nearer to 0, and only 1 value, that is Y signals, is above 260, and remaining is less than 50. So I cannot able to identify where is the yellow color or gray color or orange, etc. Here I am having 7 colors are there, but I can identify the classes. It is clear because it is this region of interest is more similar to the white signals. Right. If I am placing the 261 and 120 as a 0, it will be again entering to this another a purely white area. That is the signals. Okay, that is without knowing this enough information, we cannot. That is one of the drawback, but it is more suitable for your industrial programming applications. Okay, I think it is getting some information about the different image classification methods. Okay, or image or color identification using the labeling. But I am not going to these detailed explanations of this VA because it is a too much complicated procedure. I think it is why we are discussing it in order, we can get these concepts of the labeling or the virtual instrument engineering workbench. Then shall we, I will show you, there is another interesting topic is here, interesting topic that is related to your vision processing systems. Normally, we are dealing with the deep learning concept. That is, they need not to. I'm just writing some different programs for detecting this barcode or barcode detections or contour detection analysis or some image filtering application, etc. I'm trying to leave this and going to a deep learning concept using TensorFlow or OpenCV. Okay, I think it is my screen is shared to us. Yeah, right. Yeah, yes. Okay, we know that the concepts of the deep learning or machine learning, that is in this era, the best technologies used for the industrialists or researchers, it is a deep learning concepts. Right. I will show you the applications of the deep learning in your the laboratory or LabVIEW platforms. Okay. That is a basic example. Yeah, I'll show you this output as a first case, first level. Then we can go for this. And I will show you the only the output window. This is a simple program for identifying the malfunctioned IC base. We know that I think it is the electronics peoples as well as the CSE peoples are more familiar to the IC base. IC base, there is a socket. Normally we can sometimes call it as a socket or integrated circuitry. Okay. In this example, I am using a 16-pin IC pin base, and automatically I have to identify which IC base is a faulty state. Okay, we can see that in this example, I am placing a faulty stage in the 4th as well as the 10th levels of the IC pins. Okay, and the first, second, third, 5th, 6th, 7th, etc. It does not have any fault. But at the 4th is having a higher, it is highly damaged, and the second one is, or this one is, it is a moderately damaged. Your ultimate aim is by using your deep learning concepts or machine learning concept to identify and a malfunctions or malfunctioned product using an industrial signals. Okay, just I am trying to running this program. It is indicated that the 4th pin is having a 100% error, and the second erroneous pin is having 97. That is 0.967. That is the error level is 0.967, and this one is 1.0. So that means this is having 100% error, and this one is having a 97.76%. Okay, then by using this program, having a different types of images are placed under for testing purpose using this deep learning algorithms. I think it is, we are more familiar with this. What about the TensorFlow? Nowadays, if you're dealing with the OpenCV, it is a best programming, there is a leading programming platform for machine learning and deep learning concepts. I think it is the reason for the TensorFlow or the OpenCV is acting as a most acceptable platform to this research is that it is an open source programming platform. By using this a simple hardware called as a Raspberry Pi or a Jetson Nano, it is having maximum 5,000 or 6,000 rupees in a single board of computer. You know that Raspberry Pi is a single board of computer with an operating system supported by either Windows operating systems or Linux operating system. Nowadays, the researchers are converted the laptops or the computer systems with some graphical board or NVIDIA graphical boards. It is replaced by a single system board of computer called as a Raspberry Pi. And another advanced versions of this Raspberry Pi is there is a board called as a Jetson Nano. It is having near to 8,000 or 9,000 rupees is there, but it is having an inbuilt 128 GPU core is there. Normally, we know that our laptop is coming with maximum quad core, and Raspberry Pi is also a quad core processor. But using by giving a maximum 8,000 or 9,000 rupees, there is a single board of computer is available in the market supporting your artificial intelligence and machine learning applications. That is the board name is Jetson Nano. It supported 128 minimum 128 core GPU processor or graphical processing unit is there. But nowadays it is available with less than 20,000 rupees or 25,000 with maximum 1024 number of GPU cores. But because of this recent development or boosting or booming of the technologies for artificial intelligence and machine learning, so many hardware platforms are available in your markets. Okay, but this LabVIEW platforms is also compatible with the Raspberry Pi or Jetson Nano, any type of open source programming platforms that they support. Okay, we can leave this. What about the GPU core? We can come back to these the LabVIEW platforms. In this example, I am using a 32-bit IC platforms, and again try to train this to apply this deep learning algorithm on the given images. By using this my program, it can be detected again 3 faulty levels. But it is you can see that there are 3 faulty levels. This accurate range is 1.00 or 100% is detected. But we can say because of my program, the first one, that is I'm placing this arc arrow the pinnies, it is completely defaulted. There is no pinnies inserted into this rod, but it is founded as a 1.00 100% error. But you can compare the second one. There is a small spacings of bitties or pinnies placed on that hole, but it is again identified as 100% error. That is, my program is having it is not a 100% trained file is not there. That is why if you are having a about 90% can be represented a 100% error or 100% faulty. But industrial levels, if it is having a greater than or 10% error, it will be avoided. It will be considered as a faulty stage. It will be a damaged one. Okay, but because of after training these deep learning algorithms using this lab view, I can able to set which is your the target range. It will be 60% or 50% or 10% or the value between some upper levels and lower levels, etc., etc. Okay, it is more similar to some other deep learning algorithms applied in the OpenCV platforms or machine learning concepts. In this example, I am using a TensorFlow platforms for TensorFlow for defining this or implementing the deep learning algorithm to find the faulty status of an object. Preferably, I am using a IC base. We can try to change the database. It may be some, it may be a pen, or it may be some ports, or it may be some electronics instruments, or any things. It can be, or it may be some clothes. Every type of materials can be trained by using this TensorFlow method using LabVIEW. Because the TensorFlow is an open source programming platform that can be inbuilt into a graphical programming interface, or called as a LabVIEW. That means any type of or the new technologies or developed technologies also adaptable to the LabVIEW platforms. So if you are choosing this LabVIEW, we cannot able to confuse about whether that LabVIEW is updated to this the next coming or next months or coming era, but it will be updated with the open source programming concepts. Okay, actually the deep learning concept is most familiar to this last 1 or 2 years, but it is LabVIEW is also having the TensorFlow platform concepts. That's right. That's similar to I am having a training different number of IC bases, and it is having a better performance as per my program. I am trying to change this clarity as well as whatever the viewability. It is having a providing a better output by my trained model. Okay, I think it is needed to show this. What about the block diagram? It is a too much lengthy procedure. We have to these areas can be used to load your TensorFlow model. That is, we know that the basic concepts of your deep learning model is first we have to upload this some trained model, and we can get some CSV files and train this data for n number of signals. It may be thousands of images can be required for your deep learning concepts. Okay, by using their computer platforms, we have to set this object or source place either from their lab, either from the hard disk drive or some other removable devices, and we can apply the different types of APIs or required for performing this deep learning algorithm. Is right. That first of all, for performing this deep learning algorithm or deep learning method or TensorFlow method, the ultimate thing is that we have to get this more enough information about the image processing, then concepts of machine learning, concepts of artificial intelligence, concept of machine learning, etc., etc. Then only I can enter into the TensorFlow programming platforms. And these steps is also required for using your OpenCV or any type of textual languages program available for deep learning. But compared to the sequential programming languages or textual programming languages, need not to look into this entire signals or entire programming levels. For example, if I want to get this color combinations or color identification, by using an OpenCV program, we have to write a lot of functions and a lot of programs for implementing the color identification. But using this LabVIEW, you can just take a single icon and configure that icon depends upon the region of interest. Only single icon is required, and you can try to we have to more thorough about how to configure that icon with respect to the different input parameters and output parameters. That means we have to get enough information about the theoretical part of deep learning algorithm and TensorFlow. That is it. But after getting this information, the programming is very easy for us. Is right. These are the some concepts related to the LabVIEW platforms or laboratory virtual engineering instrument or virtual engineering workbench used in your lab or industrial as well as the scientific applications. Okay, and this software is available as a free of cost. The students version is available from the National Instruments, and this deep learning algorithms or machine learning algorithm that is also free for us. Okay, you can try to for a simple the researchers maybe they have to purchase some of the additional packages for educational purposes or academic applications or simple paper publications. You need to purchase this LabVIEW. So many block of icons or so many features are available as a free of cost by using the LabVIEW platforms. Okay, I think it is we are getting some information related to the graphical programming concepts using LabVIEW laboratory virtual engineering workbench. Okay, shall I enter into the previous yeah, we can enter into the share my screen. We can come back to this slide. Yeah, that is where come back to these concepts of the analogy between LabVIEW and LabVIEW. This is already completed. I need not to discuss about these applications on there. We can see that what are the different industries they are supporting the LabVIEW platforms. The first one is the Tata Consultancy or TCS. We can feel that what is the applications of the Tata? Already the TCS is purely a software company or software companies. They don't have any hardware development, but the LabVIEW platforms is, I already told that it is supported either C++ or Java or C programming concepts, right? Or VHDL program. Normally, if you are writing this 100 number of pages, I can represent the 100 number or 1000 number of pages of programs or C++ program into a single icon that is more vulnerable to the programmer. And if a program is developed 100, or for example, a program called as a deep learning algorithm using a C++, they can represent it as a simple function called as a function called as an icon. And this icon can be copied to some other computers. And you know too, without knowing this enough information about this deep learning algorithm, the new user can configure this a single block written by the another one. They can, it is a multi-platform or it is very transferable to the some other programmers. Is right. That is, if you are using a C++ or C program is transferred to some other programmers, it is too much difficult to study this. What about the program written by the first programmer? But the second one, or this destination program, by using this LabVIEW, it is easy to identify or easy to use this program written by some other programmers. Okay, and this also the Wipro, then Bosch, then Audi or BMW. In industrial or in the automobile industries, most probably it is one of the booming of the LabVIEW platforms. The Bosch is the first leader, and the second one is the Audi and BMW. These three are using the Volkswagen, etc. also using this LabVIEW platform for implementing their own hardware. The reason is that the programming concept is too simple. It will be transferable, and this hardware devices for this LabVIEW environment is very small. If you are entering this an embedded system devices using this C or C++ program, the hardware will be bulky because we have to purchase so many vendors. So we have to approach so many vendors, and these products can be attached into a single board. And after entering to this a single board communications, so many vendors are there, so many products are there. And interfacing between these vendors, it is also too much complicated. Some interfacing is also required. That is why that product will be bulky. But using these LabVIEW platforms, there will be a specialized hardware or dedicated hardware is available in our market. You can try to just purchase the board and program it as you want. Similar to an FPGA program or VLSI programming, you can able to reconfigure the hardware devices available from the LabVIEW. Okay, so it is better to, that is why it is more adapt or acceptable to this automobile industry, especially for the world leaders like Audi or BMW or Bosch, etc. Okay, then I can try to stop this program within the 5 minutes. If you are entering to this, before completing this program, I will show you what are the basic requirement for entering a student into a LabVIEW platforms. I mean, how can get a better job or a core jobs in industries. Nowadays, the 90% of the engineers or they are admitted to the software industries or software sections. Only few people are entering to the hardware level. For ultimate aim of these engineering students, especially from electronics or electrical, mechanical, automobile, etc., they are looking for these core companies. But there is no opportunity for these mechanical students also. Mechanical students also entering into the C programming or TCS programming concepts. Then how we can enter into a core company with a global certification program. They're having so many programs available under this LabVIEW certification. This is starting from a CLAD exam. This is a Certified LabVIEW Associate Developer. It is a entry-level program or entry-level exam conducted by the National Instruments. Okay, it is a very easy for us. Actually, if we are having a 5 or 10 days training from an expert, we can able to clear this CLAD examination. Or 2 to 3 days is training is enough. Then there are two sections are there. Then core 1 and core 2. The core 1 is only some basic concepts of the programming, similar to the structures or files, then loops, then etc. etc. And this core 2 is related with some hardware interfaces, mostly used in the embedded system. They are only dealing with a single board known as a data acquisition board. It is how to read some temperature or humidity from this external web and displayed in the LabVIEW platform. There are two sections are there, core 1 and core 2. It is very easy for us. We can able to pass this examination as very clearly with a enough training concept. That's if you are completed this CLAD examination, it is enough to enter into the Bosch or BMW or that types of core companies. Okay, if you're having certified by this class, you can and just apply directly to these types of global companies. They will definitely accept because there is a lot of vacancies are available under this class or under the LabVIEW developer stages. Okay, for example, when then the TCS are coming to our campuses after completing their interview, every time they will ask for is there any LabVIEW certified students are there? There not be no one will be there. Thereafter they will call is there any LabVIEW certified faculties are also there because there is a lot of vacancies are available in that the CLAD exam or LabVIEW certifications. Okay, for the EEE or CSE or the students who are more focusing on this hardware or core companies, it is better to go for the CLAD certification. Maximum or 15 days study is enough for clearing this examination. And I think it is most of these cities in our Kerala, they are providing this test centers. So I think it's most of the computer centers or NIT or NIIT, something, these types of computer centers having a testing center are similar to, it is a simple online examination. We can easily certify by the lab examination. And having a different levels are there. There are 4 levels of certification after this basic entry. And second one is certified LabVIEW developer, then architecture, transcend developer, and transcend architecture. Okay, I think it is. The CTD and CTA certificate persons is not available in our country or in our India. That is only we are having up to CLA or certified LabVIEW architecture certified persons is available in our India. I think it is less than 100 number of people are available in our country. CTD and CTA people are not available. Right. If you're having just clearing this CLAD examination, they are offering minimum 4.5 lakhs to 7 lakhs per annum. Okay, it is better to certify for the CLAD. And remaining CLA examination, CLA, that can be completed after 2 or 3 years with a working experience in their labs. But we can able to complete this certification by only the CLAD examination of Certified LabVIEW Associate Developer. These are a certification program. If you want to more looking into this core company, definitely we can go for this CLAD examination and try to clear it. I think it is more than 3,000 or 2,500 rupees is enough for the examination. It is also an online, better for it. Okay, these are some concepts of graphical programming platforms most suitable for even the engineers and researchers. Right. I think it is you're having better knowledge about this graphical programming language. And also, I can add it to one point. It is not limited to this language. We are having so many graphical programming languages are available in our market, but it is limited for a single application. It is not multi-targeted. For example, in robotics applications, we are having some graphical programming languages are there, but it is only reserved for the robotics development. That's right. But it is a multi-streaming or multi-engineering streams or science streams can be supported in Labi. That is why I'm choosing to introduce us the graphical programming for as a webinar topics. Okay, the dear coordinators, I can try to wind up the sections. And if you're having any doubt clearance, I can try to clarify this.